This is the bonus material for lesson 1.1 in logic. Bonus meaning you don't have to listen to this. So this is only for people who wanted more abuse. They weren't bored enough with the first one. If you were having difficulty with the first one, I definitely would just rewatch the first one and not watch this one. Or wait till you totally get the first one and watch this one. We'll talk a little bit more about what is logic and maybe different ways of doing what we did last time. So what is logic? Well, one thing I can say is I can say certain sentences that don't seem to match up exactly with things that we were talking about just now. So, for example, I could say you can have bananas in pairs, right? And I could also say this: you can have bananas and pears. The second way of saying it is a little different than the first. The first one is sort of an innocent saying, yeah, you can have them both. The second one is sarcastic, right? And so, in other words, I'm saying, no, that's ridiculous. You can't have both of those. You can't have them both. So, I'm saying sort of like the opposite of what I mean. So, if you were a very eager logic person, and you might say, B and P, right? I can have bananas and I can have pears. But if I was being sarcastic, the exact same words would not fit into this, right? In fact, it would be the opposite of this. It would be something like this: not B and P, right? It's not the case that you can have bananas and pears. So I know that logic isn't going to match up exactly with the words that we have in our everyday language. Here's another example you guys might bump into. Let's say you want to go hang out with your friends and then you want to go to the mall. And your mom says, well, either your friends or the mall, right? Either you're going with your friends or you're going to the mall. Now, what she really means is you may choose one of those two things, but not both of those two things. And I don't really care if you don't choose either of those two things. Well, logically, that's exactly the opposite of what that means, right? So either you're going to the mall or you're going to hang out with your friends. M or F. What this means is at least one of these two things is true, possibly both, right? So at least you're going to the mall or you're going to hang out with your friends. Possibly you're going to do both of them. That's what that sentence means. But I don't know what your mom means, and I guarantee you if you present her with a logical argument, she's going to say, that's great, you can stay home now, right? So one thing I know is that logic does not match up with everyday language, at least not perfectly, right? You kind of have to ask the question, what is this person saying to me? And then you can formalize it, right? So if my mom says something like that, either you're going to the mall or you're going with your friends, I would know something like this. It actually would be this right here, right? It's not the case that you're going to the mall and you're going with your friends. That's really what she means, right? So when I know what she means, I can formalize it, but I have to ask that question. So yeah, logic is an everyday language, but then, of course, what is it? Well, I like to think of it a little bit like math, right? You have, let's say you're going to do a basic problem, 1 plus 1 equals 2. When I think of 1 plus 1 equals 2, I don't think of like an actual 1 that's floating around mystically uniting to an actual other 1, and somehow, when they get married, they become a 2, right? And that's not like sodium and chloride coming together and making salt. And so, what is it like then? Well, it's kind of like 1 plus 1 equals 2. It's something in my mind, but it works in reality because reality, my mind conforms to the way reality is when I do that, right? It's sort of structured the same way. That's kind of the way logic is, right? If I say, not M and F, there's not an M that's floating around and then this guy that's actually floating around and an F that's floating around. It's just the way that there's, a formal structure that reality bends itself to, or is structured by, that has to be structured that way. And when I do this, the way that I'm thinking is structured in that same way, or in a similar way, right? Because it's not exactly the same way. Like if I say, goes to the mall, going to the mall isn't literally in my mind, right? I mean, I'm thinking about going to the mall, but I'm not actually going to the mall in my mind. Or a better example might be tree, right? If I think of a tree, there's not a literal tree in my head, right? My head doesn't have splinters in it. I'm thinking of a tree, but I am thinking of a tree and not thinking of a dog, right? So my mind is still kind of structured the way that the tree is structured, just not exactly the way it is in reality. Same thing with logic, right? It's structured the way that reality is, but not exactly the way reality is. It's in a very human way, in a thought way, right? That's exactly what logic is. It's thought structured by reality. And finally, never mind that ding. Finally, I don't know where we'll be in the class when you first see this. Probably, since it's pretty early, probably you won't see this, but say it comes up later. By proposition here, I don't mean what some people mean, the realists mean by proposition. I don't mean something that's really floating around out there. Realists will think like a proposition. When you say something like, the dog is there, and a Spanish-speaking person says, el perro está allí, you mean the same thing, right? How do you mean the same thing? Well, they say that there must be some real thing in reality, and I'll just call it a proposition for fun, and that thing is sitting out there, and when we both say those same things, it refers to that thing. They both point to this proposition that's really out there. That's not what I mean by proposition. By proposition, I mean something that's in the head. It's not out there floating around somewhere. All right, another way to do it. So I showed you the propositional calculus last time, and I showed you just by just defining everything. Well, some philosophers don't like to do it that way. Some philosophers like to start off with a fewer number of things that they define, and then from there they go on, or a few number of things as what they'll call primitives, rather. Primitive meaning they don't define. So, like, they have the knot and the wedge here, and they can say what it means in English, but that's not what they do in logic. They don't say this means whatever, right? They start off just by saying, hey, I have these two symbols, and I have these symbols over here, and then they give you a rule, and then they define some other things, and that by those you figure out what these mean, right? So, for example, they're just going to start off just with the knot and the or, and of course our symbols here, and say, by the way, here's my rule. If you have a knot and an or, if you have an A and a B and those are legit, then these are legit too. And then they'll make a definition. The first thing they'll define is the and. And they'll say A and B is defined as not both not A or not B, right? I think I said both not, either not A or not B. So A and B is this guy in here, right? So when they say A and B, and they're using this, this conjunction right here, they say it's not the case that either you are not in A or you are not in B. So if you were over here, you would be not in B. If you were over here, you'd be not in A. If you were out here, anywhere, you'd be both not in A and not in B. So if you're not in any of these places, here's where you are, right? So what they do is they start off with these guys as primitives. They're not going to say what they mean. They define these guys from the primitives, and based on that, you know what you're doing. You know what this means too. Here's another one. If A, then B. Right? So let me erase all this stuff I got on here. Erase all on the slide. They define it as either not A or B. Right? So, in other words, you can't have, let's see, not A or B. So that means either you are out here, right, in the not A, or you are in the B category, right? So if you're in either one of those two things, but see, you're not in this area right here. So you can't be in A and not be in B, and that's basically what the if-then is anyway, right? So they just define based on these guys right here, and they get the meaning that we already know. And this last one is if A, if and only if B, and it looks something like this. Using this guy right here, if you have A, then you have B, and if you have B, then you have A. Right? So why do this complicated stuff? Well, some philosophers like what they call like an economy in their philosophy, right? In other words, like they like it to be simplified. They want less stuff. So all they have as primitives are these things right here, and these things are defined off of them, they say, well, look, I have a simpler method right here. I have a simpler system. I don't know if I totally agree with that. I've read some articles that argue, hey, yeah, you may have less symbols here, but you have a whole lot of extra baggage that you have. You have all this extra stuff. Whereas if somebody just says not, or, and, they don't have all that craziness. So there are debates about it, but if you wanted to, you could do it this way. If you don't want to, you don't have to. We'll be doing it the other way in our other videos.